Now, for this next set, it says, given the geometric sequence, find the next three terms. So, from negative 21 divided by 7 gives me negative 3. 63 divided by negative 21 is also negative 3. So there's our ratio. Now, if we're going this way, we're going to have to do the opposite, so we're going to have to multiply by negative 3. So 63 by negative 3 will give me negative 189. Now we've got to take negative 189, multiply that by negative 3, and this will give me positive 567. So remember, since this one had a negative ratio, every other one is going to be positive and negative. And then 567 times negative 3 give me negative 1,701. I want you to use this principle. So find the geometric sequence, whether it's a fraction or if it's a whole number or negative. Here, we'll do one that's decreasing. We'll do number 8 real quick. So 768 divided by 3072. 0.25. Math, enter, or 1/4. So this one was 1/4. And let's just double check. Let's do the next one. 192 divided by 768 is also 1/4. So each of these times is 1/4 of that size. So you will multiply this by 1/4. Which is 48. And then 1/4 of 48 is 12. 1/4 of 12 is 3. Now, I want you to try this with both of these, get the next three terms. If you get decimals or fractions, make sure to leave your answers in fractions form, okay? Try 9 and 10 real quick. Push pause on the video until you've done it. Push pause now. Alright, so 4 divided by 8 is 1/2. 2 divided by 4 is also 1/2, so we're taking half of it. 1/2 times 2 is 1. 1/2 of 1 is 0.5, or 1/2. 1/2 of 1/2 is 1/4. Negative 5 to 25, that's by 5. Negative 125 divided by negative 125 is 5. So 5 times that each time. So 125 times 5. That's going to be negative because all these were negative. So negative 625 times 5 again is negative 3125. Times 5 again is negative 15,625. Now, there is a formula that allows you to get anything in the sequence. So, here is your formula. A to the n is equal to a to the 1 times r to the n minus 1. Now, a to the n just means a to whatever term n is. So, if they want the 10th term, a to the 10th, or whatever. A to the 1, remember, that is your initial value, or your initial term, and we know the R is just your common ratio. So now, let's use this in our formula to get any term we need. Number 11, we've got 3, 9, and 27. So we know our initial value is 3, and 9 divided by 3 gives me 3, so my ratio is times 3. My initial value is 3. 27 divided by 3 is 9, so the ratio was 3 each time. So a to the n is equal to 3 times, so we just put it in our initial first, right? Times the ratio, 3 to the n minus 1. Now for this, we cannot really simplify it, but we can plug it in from here. That's as simple as it gets. So we can put it in for find a to the 7. So a to the 7 would be 3 times 3 to the 7 minus 1. So 3 times 3, 7 minus 1 is 6. And when we do 3 times 3 to the 6th, we should get 2,187. All right, let's do one more and then we'll move to the back. So 20 divided by negative 4 gives me negative 5. Negative 100 divided by 20 is also negative 5, so there's our ratio. Our first term was negative 4. So using our formula, a to the n is equal to the first term, which is negative 4, times our common ratio, which is negative 5, times n minus 1. Now, you see all these negatives? This negative 5 is not being 5 being raised to it and the negative, but the whole thing. So this needs parentheses. So we've got negative 4 times, we've got negative 5 times, let's find it to the 7th term. So I need to plug in 7. 7 minus 1. So negative 4 times negative 5 to the 7 minus 1, which is 6. Now, you need to use parentheses and plug that in exactly. Negative 4 times negative 5 raised to the 6. Should give me negative 62,500. And I do just want to show you what happens if we don't put that in parentheses. So the sign will change. The parentheses make a difference here. Make sure you use it because that negative 5 is the whole ratio, so everything in that, including the negative, is being raised to that exponent, okay? I'm going to stop the video here. We're going to do the next video to get the back page.